water safety. Water. It's essential to life and the way we live it, but it isn't always safe. In fact, 1 in 4 people in the United States has water that's improperly monitored or unsafe to drink. The problem with current water systems is that they're only required to test your water once a year, but within the span of a year, a lot can change. Most tap water contamination comes from events such as natural disasters, chemical spills, or sinkholes opening, and all of these lead to changes in conductivity. Most typical water testing methods are expensive, inaccurate, and in general, just not accessible to the general public. That's why I created my H2Know program. My sensor is a smart solution that is accessible to the general public, it's inexpensive, consistent, and it tells you what its results mean. This is the sensor that I was able to develop. It basically has 2 wires and alligator clips that hold these graphite electrodes at a fixed distance from each other. It works by creating a voltage drop between the 2 electrodes. This passes a current from one electrode to the other. The contaminants in the water would serve as charge carriers to carry the electrons from, like I said before, one electrode to the other. And based on the voltage that I receive, I can approximate the level of contamination in the water. So here's the circuit that I use for my sensor, and it's put onto a breadboard so that I can prototype the circuit and change them around as I go. Now basically how this works is the red wire brings power up to my sensor and the black wire brings the remaining current and voltage back. Now here the circuit splits into a parallel circuit where the electrons can either go through a 10K resistor back to ground or through this yellow input wire to this microchip. This microchip allows the Raspberry Pi to read the values from the sensor and to interpret what those mean. So now this is the terminal, and I used Python to code my whole project. So here what I'll do is I will put my sensor in water and run the code. Now this says the water quality of my water is better than average tap water. So now I'll clean my water with this, I'll clean my sensor with this distilled water, and I will use it in the salt solution. Now this salt solution represents contaminated water, as the salt represents contaminants that would be in contaminated tap water. So once again, run the code, and this says that the water is unsafe to drink and has a level of 964, which is above the unsafe to drink limit. I was able to create an accessible, inexpensive, consistent, and accurate water quality sensor that not only tests your water, but also allows you to interpret the results so that you know how safe your water is. This would allow you to use your water only when you know it's safe and to detect water quality events before they occur. So in the future, I hope that we can incorporate a water quality sensor among all the other sensors in our daily lives so that we may all live safer and healthier lives. Thank you.